Now, here's the good one. And why do I say that? Well, it's a radical equation, but this time the equation contains two radical expressions, which is going to compound our solution method. It's going to make it a little more difficult. The approach still remains the same. I want to isolate the radical expression. Well, in this case, I have two of them. So the best that I can do is to isolate one of them on one side of the equation, as we already have here. When I've isolated one of them, I then want to raise to the appropriate power, which in this case, the appropriate power related to the root that's there is the second power. I need to raise both sides of the equation to the second power. Well, raising the square root of 5 minus 2x to the second power is simply going to give me the radicand there, 5 minus 2x. But now look at this side of the equation. How do I raise the square root of 2 minus x plus 1? How do I raise that binomial to the second power? Well, raising a binomial to a second power, as we saw in the previous video, is multiplying it times itself. So this becomes a problem of using FOIL to multiply the binomial times itself. Well, the square root of 2 minus x times the square root of 2 minus x. Isn't that the square of the square root of 2 minus x? Won't that simply give us the radicand again, 2 minus x? Square root of 2 minus x times plus 1, that would be the O of FOIL. Well, that's going to give us plus the square root of 2 minus x. The I of FOIL is also going to give us plus the square root of 2 minus x. And the L of FOIL is simply going to give us plus 1. Take out that pair of binomials that I simply put there so that we can think our way through the multiplication. Now let's see if we can combine some like terms in that right-hand expression. 2 plus 1, that's going to give me 3. So I have 3 minus x. I can't combine terms that are outside of a radical expression with terms that are inside a radical expression. But this says I have one of the radical expressions and I have one more. Wouldn't that be the same as saying you have 2 times the square root of 2 minus x? So our first step has at least removed one of the 2 radical expressions. So now we have a radical equation that only has one radical expression. So we should isolate that radical expression and go through the raising to the appropriate power again. So I'm going to subtract 3 from both sides, add 1x to both sides. And I will square both sides of the equation again. I'm squaring a binomial. That's FOIL. That's 2 minus x times 2 minus x. That's going to give me 4 minus 2x more. That'll be minus 4x. And then plus x squared. Minus x times minus x will be plus x squared. When I square this side of the equation, you have to be careful. Remember, when you square a product, you square each of the factors. So I have to square the 2 that's outside of the radical expression. The square of 2 will be 4. And then when I square the square root, that's going to give me the binomial 2 minus x. And now it appears we have a quadratic equation. let's put it in standard form. So that'll give us x squared minus 4x minus 4x on opposite sides of the equation is going to disappear. Subtracting 8 from both sides, I have x squared minus 4 equals 0. Oh, this is the situation of a quadratic equation that's missing its first power term. This is where we want to use the square root property as our way of solving it. So I'll isolate the squared term, and so x is equal to plus or minus the square root of 4, so x is equal to plus or minus 2. The two solutions we found for this equation are positive 2 and negative 2. So let's go back to the original equation and check those solutions. So if I take, back in the original equation, which of course didn't have the squares on each side there, if I take positive 2, it's going to give me the square root of 5 minus 2 times 2 is supposed to equal the square root of 2 minus 2 plus 1. Well, 2 times 2 is 4, so this is the square root of 5 minus 4. It's supposed to be equal to the square root of 0 plus 1. Well, the square root of 0 is 0, so that's just going to be 1 on that side. 5 minus 4 is 1, square root of 1 is 1. So x being 2 is a legitimate solution. Let's try the solution for x of negative 2. Wherever there was an x, I replaced it with negative 2. So this is going to be 5, minus the minus will give us plus 4. And this is 2 minus minus 2, that's 2 plus 2, which is 4. So I have the square root of 9 equals the square root of 4 plus 1. 3 equals 2 plus 1. 3 equals 3. We have found 2 valid solutions to that original radical equation.